Okay, so we're looking at absolute value equations and inequalities now. And so just think about it, and I think it's not too bad. If you look at the absolute value of x is equal to some number, and so let's call that number 1. There's two values, right, that you can plug in there to give us an answer. If I plug in 1, right, for x, isn't the absolute value of 1 equal to 1? Yeah. And if I plug in -1, when we take the absolute value of a negative number, absolute values are just basically the distance between 0 and that number on the number line. Distance are always positive. This is 1. So basically, if we have some expression inside this absolute value is equal to a number, we want to rewrite the absolute value equation without absolute values. And so we can do that by dropping the absolute value. We can set it to the positive of one side and the negative of the other side, or the negative of what the other side was. So for instance, so rules for solving absolute value equations. So if there's just one absolute value, then you want to isolate the absolute value on one side of the equation and get everything else to the other side of the equation. So isolate the absolute value on one side of the equation and get everything else to the other side.
Sorry about that. My phone crashed.
Oh, no worries. Get everything to one side. Everything else. Okay, so once the absolute values are isolated, or the absolute value is isolated, and we got everything else to one side of the equation, and then to drop the absolute values, we're going to rewrite it as two separate equations. So drop the absolute value. By writing two separate equations. So technically, if we had some absolute value of x is equal to a, to drop that absolute value, we have two separate things. We have x is equal to positive a, or x is equal to negative a. And then we're going to solve each piece or each equation separately. So it's possible we get extraneous solutions, so we need to check our solutions. So let's pull an example. Okay, so we have the absolute value of 2x plus 1 in the numerator, all over 3x plus 4 in the denominator. This is all equal to 1. So I've already got the one side isolated with the absolute value. Everything else is on the other side. So now we want to rewrite this as two separate equations. And so rewriting it as two separate equations, we have 2x plus 1 all over 3x plus 4 is equal to positive 1. Or we have 2x plus 1 all over 3x plus 4 is equal to negative 1. We need to be careful here because I notice we have a variable in the denominator. And so we need to put a restriction. We need that 3x plus 4 does not equal 0. So subtract 4, divide by 3. X could not be negative 4/3. It's not part of our domain. Okay, so these aren't too bad. We're going to clear the fraction. We can multiply both sides of the equation by 3x plus 4. Do it to one side, got to do it to the other. That clears the fraction, leaving us with just the numerator on the one side, which is 2x plus 1. Sorry, lost it. Low system resources may affect audio quality. Try closing some applications to improve performance. And I don't know why it's not opening up. Let's see. There we go. And I don't know why that always comes up. I don't even have an Xbox. Okay, so 3x plus 4. Come on, baby. So 3x plus 4 is cancel. We're left with 2x plus 1. This is equal to 3x plus 4. Let's get variables to one side, constants on the other. So if we subtract 3x to both sides, this gives me negative 1x. Let me subtract 1 on both sides. So this would equal 4 minus 1 is 3. So x is equal to negative 3. So that was one of the equations. Solving the other equation, start it the same way. We want to get x by itself. Let's clear the fraction. We can multiply both sides by the LCD, 3x plus 4. Our variable, or the 3x plus 4 is going to cancel there, leaving us with just the 2x plus 1 in the numerator, equals, this time then we need to distribute that negative 1. So we get negative 3x minus 4. So if I add 3x to both sides, well, 3x plus 2x is 5x. And if I subtract 1 on both sides, excuse me, negative 4 minus 1 is negative 5. Divide both sides by 5, we get x is negative 1. Okay, so we have two solutions. If they work when we plug them back in, negative 3 and negative 1. And so check, and plugging it back in, And you get 2 all times. We're going to rewrite it with -3 plus 1. 3, you see an x, put a parentheses, rewrite it with a -3. Is this equal to 1? And 2 times -1 plus 1 all over 3 times -1 plus 4. Is that equal to -1? I'm sorry, +1. So plugging in -3, this gives me -6 plus 1 is -5 in the numerator. This is 3 times -3, that's -9 plus 4 is -5. Absolute value of -5 over -5, well, this is the absolute value of 1, which is equal to 1. Plug in -1 wherever you see an x. And the other one, so we have 2 times -1 is -2, plus 1 is -1. All over 3 times -1 is -3, plus 4 is 1. -1 over +1 is -1, but the absolute value of -1 is equal to 1, and so that one also works. So we have our solution. They wrote theirs in set notation, so they put that the solution here is -3, comma, -1. Either way. Okay, so let's go ahead and take a break. Let's meet back here. Okay, so now we're looking at absolute value inequalities, and it depends on what way the inequality signs depends on how you're going to drop it and rewrite it. And so, for instance, if you had, let's just look at it with a number. So let's say we had the absolute value of x is less than 2. So I know that if I put any number in there between 0 and 2, that could make a true statement, right? Except for 2 itself. Maybe we could put the equal sign. So, right, if I put 2 in here and drop the absolute value, that would make sense. 2 is less than or equal to 2. If I put 1 in for x, absolute value 1 is less than or equal to 2, etc. Now, let's look at numbers between -2 and 0. Any number I plug in there between -2 and 0 also works, right? Because the absolute value of -1 would give +1, which is less than or equal to 2. It's when I'm choosing numbers that are bigger than 3 won't work, or smaller than -2 won't work. And so to drop the absolute values when it's a less than or equal to sign, you would sandwich it in between the negative of what's on the one side and the other side. So the rule says, and this could be some expression x in here, if you have an expression and the absolute value of that expression is less than or equal to k, where k is a real number, then in order to drop this, we can solve it by looking at -k is less than the absolute, just that expression x, which is less than k. Oops, I guess that k is a real number, has to be in there. So same sort of idea with a greater than or equal to sign. So if I have the absolute value of x is greater than some number, so let's look at this with 2. So if I choose numbers that are bigger than 2, those would work. Absolute value of a positive number is a positive number, and that would work. What about numbers, if I put in numbers that are smaller than -2, those would also work, because absolute value of like -4, that's 4, and 4 is bigger than 2. So if you don't remember what way to write the signs, kind of think about it when you're dropping the absolute value. Think about it with a real number. That's, to me, is helpful. But to drop it when it's a greater than sign or a greater than or equal to, the rule says we have some expression and the absolute value of that expression is greater than or equal to some value of k. Then to drop this absolute value sign, we have x is greater than k, or x has to be less than negative k. So or statement means both of these work. So it's this set plus this set is our solution. Okay, so let's pull out some examples. Okay, here we go. Okay, so here we have the absolute value, and inside the absolute value, we have 1 minus 2x. That absolute value, then we have a minus 4 is less than negative 1. So first step we want to do, I'll just mute everybody. First step we want to do is isolate this absolute value sign. And so we can do that by adding 4 to both sides of the equation. And so if we add 4 to both sides of the equation, we get the absolute value of 1 minus 2x. This is less than negative 1 plus 4 is 3. So it's a less than with an absolute value. And so I'm going to rewrite it. This is the one that we sandwich in between the negative. So this is the same thing as negative 3 is less than what was inside the absolute value, which is 1 minus 2x, is less than 3. So let's solve this by isolating the value of x inside or in between the inequality. So if we subtract 1 on all sides, we get negative 3 minus 1 is negative 4, is less than negative 2x, is less than 2. So this is where we got to be careful. To get that x by itself, we have to divide by a negative. And if we divide by a negative, we're going to have to change these signs. So we now have negative 4 divided by negative 2. Well, that's a positive 2. It is greater than x, which is greater than 2 divided by negative 1. I'm sorry, 2 divided by negative 2 is negative 1. So I don't tend to like to look at it this way. I like smallest to largest, and it makes more sense to me. So let's just rewrite it. So negative 1 is less than x is less than 2. So it's saying any number you chose in between negative 1 and 2 is going to be part of the solution set, and not including, because we don't have the equal to part there, so we're using parentheses. Or we would write it as parentheses negative 1 to 2. So this is how I was kind of talking about the beginning when we were looking at inequality and interval notation, that sometimes these interval notation looks like a point, but that does not mean the point when x is negative 1, y is 2. This is meaning the range of all x values between here. So what about the absolute value? We have 2x minus 3 in the numerator, all over 2. We're still inside the absolute value, but not that fraction anymore. So plus, and then new fraction, 1/3. In the absolute value, this is greater than 1. So greater than, you're going to sandwich, or not sandwich it, you're going to rewrite it as two separate ones. So we're going to rewrite it as what was inside the absolute value, 2x minus 3 all over 2, and then plus the 1/3 is greater than 1. Or we have the fact that take what's inside the absolute value, 2x minus 3 all over 2 plus 1/3 is less than the negative of this side, -1. So personally, I don't like fractions or working with fractions. So let's clear the fractions. So 2 and 3 are in the denominator. I can see my LCD is going to be 6. So if we multiply everything through by 6, so I need to multiply this first fraction by 6. I need to multiply the 1/3 by 6, and I have to multiply this one by 6. Just multiplying on both sides and distributing. Okay, so multiplying 3 by 6, that 2 goes into 6 3 times. And so we pretty much have left for that first piece, 3 times the quantity 2x minus 3. So 3 times 2x is 6x, minus 3 times 3 gives us 9, plus, well, 3 goes into 6 over here twice, so this will be plus 2, is greater than 1 times 6 is 6. So simplify the one side, we can combine like terms. So we have 6x, -9 plus 2 is -7, is greater than 6. So let's add 7 to both sides. So I have 6x is greater than 13. Divide by 6, so x is greater than 13/6. So same idea, solve for x on for the other inequality. We multiplied everything through by 6, the LCD to clear the fraction. 2 goes into 6 3 times. Distribute it to the parentheses. 3 times 2x is 6x. 3 times -3 is -9. 3 goes into 6 twice, so plus 2. But now this is less than -1 times 6, so -6. So we get 6x, combining like terms, -7 is less than -6. Add 7 to both sides, we get 6x is less than -6 plus 7 is 1. Divide by 6, x is less than 1/6. So if we put this on the number line, you have two separate pieces. Notice we have everything that is smaller than 1/6. I'm just going to write 1/6 here. So that would be a parentheses and everything to the left of that. And then we have everything bigger than 13/6. Well, that's like 2 point something. So locate 13.6 on the number line. And it's everything bigger than that. So a parentheses, because not including, and then shading all to the right. So interval notation, we're coming from -infinity. We're getting really, really close to 1/6 on the left, but not getting there. So parentheses. Union, which kind of means this set plus this set. Parentheses, starting at 13/6 or very close to on the right, but not getting there, to infinity. Okay, are you guys okay with, and remember solving absolute value equations and inequalities?
I think so.
Yay. Everybody else okay? because I'm gonna jump into the next section. We're keeping up with my husband. Got through 1.7 halfway. Okay. Okay, so the next portion, which I know is everybody's favorite, and so you're probably going to be really excited now, is applications. And just solving some word problems. And so most of these you've probably seen before. So we're going to look at motion problems, distance equals rate times time. You know, those two trains start at the same position and go in opposite directions, and how long is it going to take before they're 10 miles apart? You know, remember those? Or those mixture problems. You got 100% of bleach and you need a 70% solution. So how much water do you need to mix in there? Interest. We all love money, except owing money, right? So we'll be investing instead of borrowing. And figuring out, you know, how much interest do you have to pay on something? Well, not interest. How much interest are we going to gain on that lottery that we won, if it was there? Yep, those kind of problems, guys. Okay, I can tell you you're going to be a fun class. Let's see. Okay, so because, and this is 1.7, I don't want to write out the whole problem, and it might have been better, and maybe I'll come in on Thursday with the problems already in here. I'll tell you what page, because you guys can always look up on the book, refer to it, and you can look in the electronic textbook if needed, but we'll read through it, and then I'll pull out the important pieces, and we'll write that information down together. So maybe we just jump in. And so right now we are on page 141 in our book, and I'm going to do an even, because supposedly odds are in the back, the answer. So 28. So a motorboat heads upstream on a river that has a current of 3 miles per hour. The trip upstream takes 5 hours, and the return trip takes 2.5 hours. What is the speed of the motorboat? Assume that the boat maintains a constant speed relative to the water. Okay, so we have this boat, and we're first starting upstream, and so that means that it's slowing us down. That current is pushing against our boat, and so it's actually taking more power to go up. And so when you have current or you have wind affecting, then we need to write rate differently. So speed or rate of the boat is going to be R plus C if you're with the current. The current's pushing you, or R minus C if we're going against the current, slowing us down. Where R is equal to the rate of the boat or speed of the boat in still water. And C equals the rate of the current. Which in this case, C is equal to 3. A lot of times I like charts. And so we're going against and with the current. We know there's formula distance equals rate times time. And it tells us that when they were going upstream against the current, A motorboat heads upstream on a river that has a current of 3 miles per hour. The trip takes 5 hours. Okay, so we know that this is R minus C, and this is going to take 5 hours. When they come home, return trip takes 2.5 hours. And we know the speed is R plus C equals D. So let's use facts that we know. We know that distance equals rate times time. And if this is equal to, or speed times time, for against, well, we know the speed, which is R minus C, all times the time it took, which is 5. And then distance, when we came back, we know is the speed of the boat, which we said was R plus C, times 2.5. Although we know more, right? We know what C is. So let's go in there, instead of writing C, let's write it with a 3. So R minus 3, R plus 3 here. Well, if you're going upstream and you turn around, right, and you come back, that distance is the same. So we know the distances are the same. And so we can just look at the distance it took to go up, which was R minus 3, that quantity times 5. This has to be the same thing as the distance coming home, 3 plus 3, all times 2.5. Looks good. So simplify both sides by distributing. Distributing our 5 on the left, we get 5R minus 15. This is equal to distributing 2.5. So R times 2.5 is 2.5R plus, what's that? 3 times 2.5, that's 7.5. Get R's to one side, subtract 2.5R on both sides. So 2.5R, so 5R minus 2.5R is 2.5R. Add 15 to both sides. So this is equal to 15 plus 7.5 is 22.5. Divide both sides by 2.5. So we get R is equal to, so to get rid of fractions within, or I'm sorry, decimals within decimals, or decimals in their fraction, we can do that. Notice that we need to move this over one spot to make it a whole number. So we can do that by multiplying by a factor, a multiple of 10. So let's multiply by a fancy one, 10 over 10. So this is the same thing as 225 all over 25. I notice that reduces. 25 actually goes into 225 9 times. Okay, let me go back to what they actually asked us to find. What is the speed of the motorboat? And so R, we had defined to be the rate of the boat in still water. So the boat was going 9 miles per hour. If we wanted to know how fast they actually were going against, that was 6 miles per hour. Coming home, that was 12 miles per hour. Okay, one more. And I'm just kind of just grabbing them. Okay, so construction. This is probably more realistic. So a pond is enclosed by a wooden deck that is 3 feet wide. the fence surrounding the deck is 100 feet long. A, if the pond is square, what are the dimensions? I'm not sure what they're asking. Okay, so you have a pond. Well, actually, sorry, we don't know if the pond is round like that. We have some pond. It's enclosed by a wooden deck that is 3 feet wide. The fence surrounding the deck is 100 feet long. Is that how you guys read it? So if the pond is square, what is the dimensions? So basically, I'm not sure if they're just telling, it doesn't make sense to me.
Are they saying that the perimeter is 100 feet long, not just side?
So again, so a pond is enclosed by a wooden deck that is 3 feet wide. The fence surrounding the deck is 100 feet long. It doesn't sound, I'll go back to that one. Let's not do that one. But I will go back and see what they're, because to me, it's just not, you know, I don't know if the deck is coming out like this and that the pond is in here somewhere. Or is this all enclosing the whole pond? But that just doesn't make sense. Logically, to me, what they're saying doesn't make sense. Or they're not explaining it to me well enough. Although you guys probably, we always kind of feel that way, huh?
Yeah, I kind of have an idea. I don't know how to explain it. If you want me to try, I can try it, but yeah.
Okay.
So essentially, you have a pond. This is how I see it. You have a pond, and then around that pond is like 3 feet around it. And then that's the deck. And then around that's 100 feet of fencing. That's what I think.
Okay.
But I'm not sure.
Okay. That makes a little more sense then. Okay, so let's see. So a pond is enclosed by a wooden deck that is 3 feet wide. Okay, so it's enclosed. It's so we have this deck around the pond, right? That we can walk around. That makes more sense. Thank you for clarifying. So we know that this length in here is 3 feet, right? We know that this length in here, that width right there is 3 feet. 3 feet. 3 feet. I cut it like this. And then, my eyesight's not good. The fence surrounding the feet, surrounding the deck, so it's all around the deck, is 100 feet. Okay, so to me, then that's telling me my perimeter. And so we can say this is width, this is width, this is length, this is length. Our perimeter is equal to twice the width plus twice the length. We know 100 is equal to 2W plus 2L. But we also know information about this that can help us. We know about that 3 feet. So what if we call, we know this is 3, we know this is 3. So how can we express this? We know that and I don't know if we want to call this some other variable. Maybe call it y. Actually, no, let's not do that. So technically we know this whole thing is w. If we need to know what this piece is in here. So let's call that y. So we know that in our case that w, well, it's equal to this piece in here in between, which is y, plus this 3 feet, because we know that's the width of the deck, plus the other 3 feet. So same kind of idea that we can do with L. Well, if we call this piece right here X, well, we know that this is 3 feet and this is 3 feet. So we know that L is equal to X plus 3 plus 3.
Professor, if you write it as x plus 6, would that be the same thing?
Yes, so I would simplify that. And so W, then we could say is the same thing as y plus 6. And we can say that our length is the same thing as x plus 6.
And do you think it
The thing is that we don't want these both in either terms of x and terms of y. We should have enough information. So we have a 100 is equal to 2 times the width, which is y plus 6, plus 2 times the length, which is x plus 6. Let me just reread. So if the pond is square, what are the dimensions?
If the pond is square, does that mean that x and y are equal?
Yeah. So if the pond is square, exactly, we know, and there was the little bit of information I was missing that I needed. So the pond is square, and so x is equal to y. So length and width have to be the same. So let's just go back in there and substitute that in. I know that I can rewrite y as the same thing as x. So I have 100 is equal to 2 times the quantity x plus 6 plus 2 times the quantity x plus 6. Let's distribute that 2. So we have 100 is equal to 2x plus 12 plus 2x plus 12. Combine like terms on the one side. So 100 is equal to, I said it, but I wrote something different. 2x plus 2x, which is 4x. And then 12 plus 12 gives me plus 24. So let's subtract 24 on both sides. And that would give me 100 minus 24 is 76 is equal to 4x. So divide both sides by 4. 2 goes in there 20 times. So that would give me 14. And then we need to look at what dimension, and they were talking about things being in feet. So what, if the pond is square, what are the dimensions? So the pond And we had chosen, right? We had chosen this piece. So this is just the deck, or this is the pond. This is the X and this was the Y. So the pond is 14 feet by 14 feet. So you could write it like this. Okay. So I'll bring in a couple different types on Thursday that we'll look over. And then we are done with chapter 1 and jumping into chapter 2. And I had mentioned again that I think chapter 2, it should be review for you guys, but I think it's a lot faster or easier than chapter 1 was.
Professor,
Mm-hmm.
isn't 76 divided by 4 19?
Is it?
Yeah.
Yeah, that's what I got.
Good. Yeah. So 4 goes in there. You're right. I don't know what I was doing. I was trying to make sure you guys were awake because I don't know if I am. Yeah, so 4 goes into 7 once with a remainder of 3, right? And 4 goes into 36 9 times. All right? Did I just do that right? Okay. So it's 19 by 19 feet. Okay, I'm glad I didn't stop the video before you said that. And caught that. Thank you.